13.2. The first question: a solid is in the shape of a cone standing on a hemisphere. Alright, so you can see the cone here, right? This is the cone that is standing on top of a hemisphere. And now the question is saying with both the radii being equal to 1 centimeter. Okay, so the radius of both the cone and the hemisphere equals 1 centimeter, and the height of the cone is equal to its radius. So we know the radius of the cone is 1 centimeter, which means even the height is equal to 1 centimeter. All right, just going to find the volume in terms of pi. Okay, so how do you find the volume of this object here? Volume of the cone plus volume of the hemisphere will give us the volume of the solid. Okay, so let's do that. So you can see I've written that given here, radius of the cone equals radius of the hemisphere, right? They're both equal to 1 centimeter. Even the height of the cone is 1 centimeter, because remember they already said the height of the cone equals the radius. Okay, now volume of the solid, how do we get? Volume of the cone plus volume of the hemisphere. Then the volume of the cone, the formula is 1 by 3 pi r square h. Then volume of the hemisphere 2 by 3 pi r cube. Okay, so pi, you just leave it as it is and put the value of radius and height, right? So we already know they're both equal to 1 and 1 centimeter. Okay, so I put there same thing, keep the pi as it is, and the radius of the hemisphere is also just 1, right? So when we multiply, you know, the 1 ones, it will always be 1, right? So nothing to do, I'll be simply left with 1 by 3 pi, and this side will be left with 2 by 3 pi. Now let's try to find the LCM. When you look at the denominator, they have the same denominator, which means the LCM will be same, right? So 3, and because they're denominators are same, just write down whatever is on top. So on the top we have here pi, and then this other side I have 2 pi, right? So you can see pi plus 2 pi. So pi plus 2 pi will give me 3 pi, right? I can divide this 3 and 3, and then I'll be left with pi. And remember that will also find in terms of pi, so our value will be pi. Okay. Alright, the next question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with 2 cones attached at its 2 ends by using a thin aluminum sheet. Alright, so you can see 2 cones attached, right? The first cone is here, the other cone is here, right? Attached is 2 ends, okay? And this is the cylinder. So there's a cylinder and there are 2 cones attached, one at the top and one at the bottom. Alright, it is doing by using a thin. Alright, then the diameter of the model, right? The diameter of the model is 3 centimeter, which means from here till here the diameter is 3 centimeter, and its length is 12 centimeter, which means the total length, okay, from the top to bottom is how much? It equals 12 centimeter. If each cone has a height of 2 centimeters, so each cone, right? So from here till here is 2 centimeter, from here till here is again 2 centimeter. We have to find the volume of air content in the model that Rachel made. Okay, so how do you find the volume of this model here? Volume of the cone plus volume of the cylinder plus volume of this bottom cone again. Okay, when I add the volume of these 3 objects, we'll get the total volume of this model. All right. So diameter given, right? If diameter is 3, then obviously radius will be 3 by 2. Height of each cone is 2 centimeter, already given. Now see, one thing you'll notice here is that I do not have the height of the cylinder. Okay, we'll try to find this first. Alright, so you can see I've written total height of the model is 12 centimeter, right? And it's made of what? Height of the top cone plus height of the bottom cone plus height of the cylinder, right? When I add these 3, do we get the entire height of the model? We get the entire height of the model, right? Which is equal to 12 centimeter. Now height of the top cone we know 2 centimeter. Height of the bottom cone is also 2 centimeter, right? Remember, we're trying to find the height of the cylinder, right? So now this 2 plus 2 is 4. It will go to the other side, and when I subtract, I'm going to get the height of the cylinder, which I have taken here to be capital H. We'll get it to be 8 centimeter. Okay, which means from here till here is 8 centimeter, right? And 8, 9, 10, 11, 12, right? So now we already got the height of the cylinder. Now we'll try to find the volume of air content in the model. So like I said, volume of the 2 cone, because remember there are 2 cone, right? One at the top and one at the bottom, plus the volume of the cylinder. All right, so volume of the 2 cone, you can see 2 is here because there are 2 cone, right? And the volume of the cone in the formula is 1 by 3 pi r square h, and volume of the cylinder is also pi r square h. Remember, I took it to be capital H, so it's not to confuse with this h. All right, so now once we're done with that, we'll try to take the command. If you look here, I can take pi r square command, right? So you can see I've already taken it out. If I've taken out pi r square from here, what I'll be left with, this is 2 1 2, so I'll have a 2 by 3, and h is left, right? So 2 by 3 h. Here this pi r square has been taken out. What is left? The capital H. Okay, so now let's put the value. Pi is 22 by 7, radius is 3 by 2, right? Square means 2 times, right? That is why 2 times. Okay, then 2 by 3 I've written here. Then h, what is the height of the cone? Height of the cone is 2 centimeter, right? And what is the height of the cylinder? We just found it to be equal to 8. Okay, If we're done with that, let's divide 2 1s and then 2 11s. Do you need to write? Can't do anything else, just write down everything down. And then if I multiply 2 2s, I'll get 4, right? So I'll have 4 by 3 plus 8. Now we'll try to find the LCM here, okay, of this 4 by 3 plus 8. You'll see it will be just 8, right? What is my first numerator? 4. So I've written 4. 3, how many times are 3? 3 1s are 3. My next numerator is 8, so I've written, remember, below 8 1 is there, right? So here remember 1 is there. The 1, how many times is 3? 1 3 is a 3. Okay, so now if we're done with that, then I can just simply multiply, right? 4 1s are 4, 8 3s are 24, right? Then 4 plus 24, I'm going to get 28. Now I've already opened a bracket. We can still divide. 7 is 7, 7 4s are 28, 3 1s are 3 1s are 3, then 3 1s are 3, then again 2 1s are 2 2s are 4. Then I'll be left with what? 11 into 3 into 2. So if you multiply, we're going to get 66 centimeters square. That is the whole volume of this model here. Okay.